Hi everyone, welcome to Lecture 15 on Basic Inorganic Chemistry. My name is Dr. Teresa Chimamban. For today's lecture, we will cover acid-base titration calculations. Okay, so let's look at some acid-base analysis practical examples. Question 1. 50.30 ml of 0.2321 mole KOH is needed to titrate 25 ml aliquot of a solution of H3PO4 of unknown concentration according to the equation below. And you are asked to calculate the concentration of H3PO4 in the original solution. So, to answer this question, first of all, we write down the titration formula, which is MaVaNb is equal to MbVbNa. Ma is the molarity of the acid, Va is volume of the acid, Nb is number of moles of the base, and you get this from the balanced chemical equation. So Nb is number of moles of base. The base is potassium hydroxide, so Nb is 3. Mb is molarity of base, Vb is volume of base, and Na is number of moles of the acid, which you get from the balanced equation. So Na, number of moles of acid, is 1 because there is no number here. So, because we are asked to calculate the molarity of the acid, we need to make Ma the subject of this formula. And to do that, we divide both sides by Va and B. So we divide this by Va and B and divide this by Va and B. So if we do that, we will get that Ma is equal to MbVbNa divided by Va and B. So once we have the formula for Ma, molarity of acid, which we are asked, we can then substitute the values from the question in this formula. So Mb, molarity of base, is 0.231 mole. That is what is given here, 0.231 mole KOH. And volume of base is given as 50.3 ml. We put it here. Number of moles of acid is 1 from the balanced chemical equation. We put it here, divided by volume of acid. Volume of acid is given as 25 ml. We put it here, multiplied by number of moles of base, which we get from the balanced chemical equation, which is 3. We put it here. So if we solve this, we will get that the molarity of the acid is 0.1557 moles. Let's look at another example. 28 ml of NaOH is titrated with 0.15 mole HCl. The end point is reached at 39.20 ml. What is the molarity of the NaOH? This is the balanced equation for the reaction. So the first thing you do is to write the titration formula, which is MaVaNb is equal to MbVbNa. But because we are asked to calculate the molarity of the NaOH, which is the base, we need to make Mb the subject of this formula. And to do that, we divide both sides of the equation by VbNa so that this Mb can stand alone. So if we do that, we will get that Mb is equal to MaVaNb divided by VbNa. So once we have the formula for our Mb, we can then substitute all the values that we are given here in this formula. So if we do that, Ma is given as 0.15 mole. We put it here. Volume of acid is 39.20 ml. We put it here. Number of moles of base is 1 from the balanced equation. VB, volume of base, is given as 28 ml. We put it here. And Na is number of moles of acid, which is 1 from the balanced chemical equation. So if we solve this, we will get that the molarity of the base is equal to 0.21 mole. So let's look at another example. What volume of 0.04 mole potassium carbonate is required to neutralize 40 ml of 0.07 mole phosphoric acid? So this is the balanced equation for the reaction. So the first thing you do is to write the titration formula, which is MaVANB is equal to MbVbNa. But because we are asked to calculate volume of potassium carbonate is a base. So we are looking for Vb, volume of base. So we need to make volume of base the subject of this formula. So we divide both sides of the equation by MbNa. So if we do that, Vb will be equal to MaVANB divided by MbNa. So once we have the formula for the volume of base, which we are asked, we then substitute all the values in the question in this formula. So molarity of acid is 0.07 mole, so we put it here because it says 0.07 mole phosphoric acid. Volume of acid is 40 ml. It says 40 ml of 0.07 mole phosphoric acid, so we put it here. Nb, number of moles of base. The base is potassium carbonate, 3. So that's 3, the number of moles. We put it here. Divided by molarity of base is 0.04 mole because we are given 0.04 mole potassium carbonate, which is the base. And Na is number of moles of acid, which is 2. Phosphoric acid, the number of moles from the balanced equation is 2. So once we substitute all the values, we then do the division and we'll get that the volume of the base is 105 ml. Let's look at another example. What is the molarity of a solution containing 0.5041 gram of H2SO4 in 210 ml of water? For this question, we will not use the titration formula because we are only giving the mass. We are not giving volume. So, because we are only giving mass, we are not giving the volume of the acid, we will not use the titration formula. So we use another formula, which is given by moles equal to mass divided by molecular weight. So the mass that is given is 0.5041 gram. We put it here. And the molecular weight of H2SO4 is 98 gram per mole. So we put it here. So when we divide, we will get that the moles is equal to 0.005 moles. So once we get the moles, we can then calculate the molarity that we are asked to calculate. So molarity is given by the formula molarity equal to moles divided by volume. And that volume must be in liters. So it is important to remember that the volume must be in liter. So if you are given the volume in milliliter, you must convert it to liter. So we are given our volume in milliliter. The volume of water was given in milliliter. So we need to convert it to liter. So to do that, we divide the milliliter that is given, we divide it by 1,000. So if we do that, we will get 0.21 liters. So if we put in this value here, in place of volume in liters, we put 0.21 liters, and we put the moles that we already calculated here. We put it here. So if we do that, we'll get that the molarity is equal to 0.024 moles per liter. So this is how to calculate molarity when you are given the mass. First of all, you need to calculate moles, because if you do not calculate moles, you will not be able to calculate the molarity, because molarity is equal to moles divided by volume. That is the reason why you need to calculate moles first. So after calculating moles, you need to check from the question whether the volume is in milliliters. If it is in milliliters, you need to convert it to liters by dividing by 1,000. So once you do that, you can then substitute the values in this formula and you can then calculate your molarity. So now we look at common acids. So the first one is monoprotic acid. What is a monoprotic acid? A monoprotic acid is an acid that contains one acidic proton. Examples are HCl. This is the acidic proton. Another example is HNO3. This is the acidic proton. Another example is acetic acid. This is the acidic proton. And for HNO2, this is the acidic proton. Another type of acid is diprotic acid. What is a diprotic acid? A diprotic acid is an acid that contains two acidic protons. An example is H2SO4. So this is the two acidic protons. Another type of acid is triprotic acid. A triprotic acid is an acid that contains three acidic protons. An example is H3PO4, and this is the three acidic protons. Now we look at how to identify acidic hydrogen. Acidic hydrogen is any hydrogen atom attached to more electronegative atoms like fluorine, oxygen, chlorine, and can be dissociated into ions. Examples are HF. So this H is attached to fluorine, which is a more electronegative atom. So when HF dissociates, it will form hydrogen ion and F with a negative charge. Another example is H2SO4, which has two acidic hydrogen. In CH3COOH molecule, only this last hydrogen atom is attached directly to the oxygen atom. So this hydrogen highlighted is the acidic hydrogen. This hydrogen is not an acidic hydrogen because it is attached to carbon. So, because carbon is not a more electronegative atom, this hydrogen is not acidic. So the acidic hydrogen is this hydrogen. So this is where I'm gonna end today's lecture. Please like this video and subscribe, and I will see you in the next lecture.